Good day to you all. Today I am going to do the first chapter of the grade 8 government syllabus, number patterns. Let us see what are number patterns and terms of a number pattern. You know what a pattern is. A pattern is something sequential. You have seen patterns in your clothing, in some decorations, like that. In mathematics also there are patterns and we show them in numbers. Let us write the odd numbers from 3 to 11 in ascending order. Ascending order means from smallest to biggest value. Then what is the opposite of ascending? Descending. Descending means from the biggest to the smallest value. Okay, now they have asked us to write the odd numbers from 3 to 11. You know what are odd numbers? Odd numbers are when we divide something by 2, if the remainder is 1, then that is an odd number. Then what's the opposite of odd? Even. Even number is when we divide that number by 2, we do not get any remainder. Then that is a even number. Okay, now we have to write all the odd numbers from 3 to 11 in ascending order. What we have? 3, 5, 7, 9 and 11. These are the terms in this number pattern. When numbers are written in a certain order according to a specific method or rule, starting from a certain number, it is called a number pattern. Every number in a given number pattern is called the term of the number patterns. So when we see 7, the 7 is a term of the number pattern, which the number pattern is odd numbers from 3 to 11 in ascending order. The first number of a number pattern is called the first term, and the following numbers in order are called the second term, third term, fourth term, etc. Commas are used to separate the terms of the number pattern. So these are the rules of writing number patterns. Keep them in your mind. Let us consider again a number pattern, the same number pattern. The first term of the above pattern is 3. The fourth term is 9. See, 1, 2, 3, 4. Yeah, the fourth term is 9. There are only 5 terms in this number pattern. Therefore, this number of terms is finite. What is finite? Finite means the number of terms are fixed. Let us write the even numbers starting from 2 in ascending order. Here I explain you what even numbers are. From 2, and they have not given a limit. So this is a continuous one and it goes up to infinity. So these types of number patterns we call as infinite number patterns. In infinite number patterns, we can't find the last term of such pattern. To resemble it as a infinite number pattern, we use these 3 dots to remark that this number pattern is continuing. There's a note. A number pattern with the first, second and third terms equal to 2, 4 and 8 respectively is given above. We can easily write 2 different number patterns with the above first 3 terms. Let us see them. One is 2, 4, 8, 16, 32, 64. In every number pattern there is a pattern, right? That means this series is gradually increased due to some mathematical operation like addition, multiplication, or else it can be subtraction, division also. Throughout this lesson, I think we are talking only about the ascending ordered patterns. That means the gradually increasing patterns. So we will come across most of the time additions or multiplications. Okay. Now when looking at this term, here a term is multiplied by 2 to get the next term. Shall we check it? Yeah. Here we have 2. The second term is 4. How have they obtained 4? We are multiplying the first term by 2. 2 into 2 is 4. Okay. Third term, see, they have obtained 8. How have they obtained? We have multiplied the second term by 2. Means 2 into 4 is 8. Fourth term, 16. How they have taken 16? They have multiplied this 8 by 2. 8 into 2 is 16. Such way they have formed this number pattern. Let's see the next one. They have 2, 4, 8, 10, 20, 22, 44. How has this number pattern come? Here the second term is obtained by adding 2 to the first term. The third term is obtained by multiplying the second term by 2. The fourth term is obtained by adding 2 to the third term, etc. Let's see whether is it true. Second term is obtained by adding 2 of the first term, 2 to the first term. 2 plus 2, 4. Okay. Third term is obtained by multiplying the second term by 2. We have multiplied this by 2. Yeah, 8. That's correct. Fourth term is obtained by adding 2 to the third term. When 2 is added to 8, we get 10. Okay. An important factor that can be learned from this is that there can be more than one number pattern having the same first few terms. Keep it in mind. Okay. Only if the first 3 terms are given, we cannot decide the rest of these terms, because more than one number pattern can hold the same first 3 terms. General term of a number pattern. Let us consider how we can easily find any term of a number pattern. See, this little guy have a question. To find the 103rd term of this number pattern. Well, is it possible to continue writing this 1, 2, 3, 4, 5, 6 up to 103? No, it's something ridiculous. Let's see whether do we have an easy method. When the nth term of a number pattern is written as an algebraic expression in n, it is called the general term of the number pattern. So, using the general term of the number pattern, we can find any term of the number pattern. General term of the number pattern of the multiples of a number. Let us consider the number pattern of the multiples of 2 starting from 2 and written in ascending order. This number pattern is 2, 4, 6, 8, 10, etc. Although the terms from the 5th term onwards are not written, we know that the 5th term is 10, 6th term is 12 and the 7th term is 14. Let us find the nth term of this number pattern. In the table given below shows how the value of each term is obtained. First term, right, 2 into 1. Second term, 2 into 2. Third term, 2 into 3. Fourth term, 2 into 4. 10th term we can obtain by multiplying 2 by the number of the term. And nth term is 2 into n. So according to third column of the table, nth term of the above pattern is 2 into n, 2n. Got it? Okay. Nth term of this number pattern is 2n. This is called the general term of this number pattern. By substituting suitable values for n in 2n, we can obtain the values of the relevant terms. The value of the n in the general term of a number pattern should always be a positive integer. Keep that in mind, okay? Always n is a positive integer. The above number pattern is the same as the even numbers starting from 2 and written in ascending order. Okay, so the general term is 2n. The general term of number patterns of multiples of 2 starting from 2 and written in ascending order is 2n. So even numbers and multiples of 2 both are same. Now let's go into an example. The general term of the number pattern of the multiples of 3 starting from 3 and written in ascending order is 3n. Obviously, that's true. Okay, let's see the first one. Find the 13th term of this number pattern. Simple, right? Substitute 13 instead of n here. 3 into 13. That's the answer. 39. Find which term is 87 of this number pattern. Here we have to find the term number, not the value of the term number. They have given the value as 87. It's simple, right? The general term is 3n, so we have to make 3n equals 87, form that equation like this, then divide both sides by 3 to remove this 3 from n to make the n the subject. The answer is 29. So 87 is the 29th term of this pattern. Now we have a table to fill to find the first term and the general term. Keep your eyes off from this table for a moment. The number pattern they have here 5, 10, 15, 20. Obviously, we can see this is multiples of 5, right? So the first term is 5. General term can be 5n. This is also multiples of 10. First term is 10. General term is 10n. Next one, 8, 16, 24, 32. This is also the multiples of 8. So first term is 8. General term is 8n. Similarly, you can find solutions for these three terms also. General term of the pattern of odd numbers. See, odd numbers are when we divide that number by 2, the remainder is 1. So we are going to identify how the pattern of odd numbers is developed by considering the following table. Okay, first term should be obviously 1. Second term should be 3. Yeah, they have given. How have we obtained the 3? Multiples of 2 is 4. 4 minus 1 gives 3. So, the general term of this pattern of odd numbers starting from 1 and written in the ascending order is 2n minus 1. Keep this in your mind. Now, let's see this example. In the pattern of odd numbers 1, 3, 5, 7, etc. starting from 1. What is the general term? General term, yeah, we found the general term previously, that is 2n minus 1. What is the 72nd term? 72nd term means, so we have to substitute for this n 72. See, when n equals 72, the 72nd term is 143. Complete this calculation and you can get it by your own. Next one. Let us take that 5 51. Sorry, 51 is the nth term of this number pattern. Then we have to find which term is 51. To find which term is 51, what are we going to do? You know that 2n minus 1 is 51. We have to make n the subject of this formula, and we have obtained n equals 26. So 51 is the 26th term of this number pattern. If you have any doubts, please mention them in your comments. Now let's see general term of patterns of the square numbers. Grade 6, that 1, 4, 9, 16 are the square numbers written in ascending order. This pattern is represented by square-shaped figures consisting arrangements of dots is given below. Okay, first one, 1 into 1, that means 1 squared is 1. 2 squared is 4. 3 squared is, 3 into 3, 9. 4 into 4, 16. The pattern of square numbers is developed as follows. So, the 10th term can be 10 into 10. So, the nth term is obviously n squared. So, the general term of pattern of the square numbers starting from 1 and written in ascending order is n squared. So, keep this in mind. Actually, this you don't want to keep this in mind. There's something like general knowledge, isn't it? The general term of the pattern of triangular numbers. You have learned in grade 6 that 1, 3, 6, 10, 15 are the triangular numbers. Hope you know what the Pascal triangle is. Yeah, Pascal triangle is also something like this. So, we'll see how are we going to find the general term of the pattern of triangular numbers. Yeah, the first triangle is 1. Second one is 1 plus 2, 3. The third one is 1 plus 2 plus 3. The fourth one is 1 plus 2 plus 3 plus 4. You can see there is some increasing order here. We'll find it. What's that? Rectangular shaped arrangements of dots that have twice the number of dots as each corresponding figure in the triangular number pattern can be obtained by joining together two equal triangles of the triangular number pattern. Okay, now let us build a relationship. To that, I'm taking two of the triangular numbers. You can see one in pink and one in blue. Okay, I'm joining these two. The triangular numbers 1, I'm joining these two. Then the second triangular numbers, joining them, third one and fourth one. Now let's see how many number of rows, how many number of columns, and let's try to build some relationship. Yeah, here we have only one row. Here when we join these two, we get 2 rows. Here there are 3 rows, and here you can see 4 rows. When you see number of columns, 2 over here, 3 over here, 4 over here, 5 over here. Yeah. Now total number of dots. When we multiply number of rows by its column, we can get the total number of dots. Yeah. Then the triangular number. To get the triangular number of them, obviously we can divide this by 2 because we have combined two triangular numbers and form this. If we divide it by 2, we get the triangular number. So, when looking at this, the pattern of triangular numbers is as follows. First term, 1 into 2 divided by 2 gives 1. 2 into 3 divided by 2 we get 3. 3 into 4 divided by 2 we get 6. 4 into 5 divided by 2 we get 10. So, the 10th term is, so in here you can see in the left hand side you get the term number, and we multiply it by adding 1 to the term number and we divide it by 2. You got me? See, the nth term we get n into n plus 1. 1 more than the term number. And we divide it by 2. So the general term of triangular number pattern becomes n into n plus 1 divided by 2. Okay, we are at the end of our lesson. Let's see the summary of what we have done today. The expression in n obtained for the nth term of a number pattern is called the general term. The value of n in the general term of a number pattern should always be a positive integer. You have to keep it in mind always. N is a positive integer. The general term of the number pattern of the even number starting from 2 and written in ascending order is 2n. Even number, right? Even number is always something we can divide by 2. So simply remember it as 2n. The general term of number pattern of odd number starting from 1 and written in ascending order is 2n minus 1. Now always odd number is, if we divide that number by 2, we get a remainder 1. So this should be obviously an odd number. So 2n minus 1 is the general term of the number pattern of odd numbers. The general term of pattern of square numbers starting from 1 and written in ascending order is n squared. You know, square is something into something. So n squared is the general pattern. General term of the triangular number pattern starting from 1 and written in the ascending order is n into n plus 1 divided by 2. Okay, you have something to think. What is it? Can you construct 3 different number patterns with 1, 2, 4 as the first 3 terms? Shall we try? Okay, I found 3. And the explanation is left to you. Thank you for watching. Please do like our videos, subscribe our channel and share our videos with your friends for them to enhance their knowledge. Thank you for being with us.